Hey guys, instead of just posting a normal answer key, I decided to make a little video answer key. All right, so I'm going to go over, not only going to, write the answer to each problem, I'm going to show you how each and explain how each problem is done. All right, I'm going to make this video so you can skip through. So if there's certain ones you want to figure out, you can be able to skip through the video to see an explanation of this. Hopefully this will help if answer any questions you guys have on this stuff. We'll still go over any questions you have in class, but just thought this might be helpful. All right. So for number one, all right, we are just going to treat this just like any other problem. If it was X, all right, we're just going to distribute. All right. So 4i times 7, 4i times 7, all right, it's just going to be 28i. 4i times negative 3i is negative 12i squared, just like x times x is x squared, I times I is I squared. Now remember, I squared is equal to negative 1. So this is just like negative 12. Now I'm not going to do this for every one, but you should know that I squared is negative 1, and negative times a negative is a positive, all right? So you end up with 28. This is really plus 12, but I can't write 28 plus 12 because I want to write it in standard form. So it's 12 plus 28i. All right, so whenever you have I squared is just equal to negative 1, you just change the sign. So negative 12i squared is just 12. All right, number two. All right, we cannot have I in the denominator. We need to rationalize this, all right? We need to get rid of it by multiplying by the conjugate. The conjugate of 5 minus I is 5 plus I. All right, so when we do the top, all right, just foiling. 3 times 5 is 15. All right. We get 3 times I is 3i. I times 5 is 5i. 3i and 5i is 8i. And then I get plus I squared all over. Now these are conjugates. The middle terms will cancel. So just 5 times 5, which is 25. Negative I times positive I, which is negative I squared. All right. So here, now we simplify. I squared is really negative 1. So 15 minus 1 is, and negative 1 is a 14 plus 8i over negative I squared is really plus 1. So over 26, right? I need to separate this, right? 14 over 26 plus 8i over 26. 14 over 26 is 7/13. 8i over 26 is 4i over 13, or 4/13 I. Doesn't make a difference how you write it. And there's your final answer. All right, for number 3. As soon as you see a negative inside the square root, just take it out. Whoops. Sorry about that. All right, so as soon as negative, we can make it positive in there by just doing an I. So it's I square root of 242. Now, you should know that 242 is 121 times 2, and 121 is just square root of 11, right? It's just 11, so it's 11. So we take out the 11, because that's a perfect square. 11i, the 2 we left over, so that stays on the middle. 11i root 2 is your answer for that one. All right, 4. All right, this is just a normal combining like terms, but you have to distribute the negative. So this is really a negative 13 and a negative 3i. So the 6 minus 13 gives me a negative 7. The negative 4i, the negative 3i is negative 7i. All right. All right. 5. All right. Now, I cubed plus I to the 7th plus I to the 5th. You cannot just add all of these up. All right, it's not multiplication, it's addition. You can only combine them if they were the same. So you have to convert these using the cycle of I. All right, I cubed is really negative I to the 7th is also negative I, right? Because there's a remainder of 3. 4 goes into 7 one time with a remainder of 3. Anything remainder of 3 is negative, the same thing as I cubed, which is negative I. I to the 5th is just I. All right. All right, so I get negative I. Negative I is negative 2i. Negative 2i plus I. The answer is just negative I. All right, and just a little recap. Remember, you have I, which is I to the first. I squared is negative 1. I cubed is negative I to the 4th is 1. And then it repeats. I to the 5th would be I to the 6th is negative 1, I to the 7th is negative I to the 8th is 1. So anytime you divide by 4, the remainder is 0, it's 1. If the remainder is 1, it's I. The remainder of 2 is negative 1. The remainder of 3 is negative I. All right. Moving on. Number 6. All right. So we have two things here. All right. We have, if it was just a square root of 7, we would multiply the top and bottom by the square root of 7, right? But it's not just a square root of 7. You also have an I. So to get rid of I, you got to multiply by I on the top and bottom. So it's I root 7. So we end up with 3 times I, which is 3I root 7 over I times I is I squared. Root 7 times root 7 is just 7, but I squared is negative 1, so it's really a negative 7, all right? So you end up with negative 3I over 7 over, this should be positive, negative 7. I already moved the negative up, just keep the negative there, all right? And then, you can leave it like that. You can write it as negative 3/7 I root 7. All of these, both of these, any of those things would be appropriate answers. All right, I'd be okay with either of those. All right, so number 7 is very similar to number 1. We're going to distribute, and I'm going to get 10I minus 20I squared. 20I squared is just really positive 20, so I get 20 plus 10I. There's my answer. All right. Now, be careful with number 8. 8 means 3 plus 2I squared. It means 3 plus 2I times 3 plus 2I. This is not a conjugate. So we are actually multiplying 3. We have to FOIL it out. Now, hopefully you guys know the trick when you shouldn't have to really FOIL this out. You should know that when you have something, a binomial squared, it's the first term squared, which is 9. Then to get the middle term, you take the product of these and then double it. So 3 times 2I is 6I, which means you get 12I. And then you square 2I, which is 4I squared. 4I squared is really negative 4. 9 and negative 4 is 5. So you get 5 plus 12I. All right. Remember, this thing here really becomes negative 4. Whenever you have something I squared, just changes the sign. All right, so positive 4I squared was really negative 4. 9 minus 4 is 5. And then remember, we have to write it in standard form. All right, have to write it in standard form. All right, so moving down to number 9. Now, the difference between number 9 and number 8 is, number 9, we were doing the same thing, 3 plus 2I times 3 plus 2I. Here, 5 plus 4I times 5 minus 4I. All right, these are conjugates, which means we don't have to multiply. We should FOIL everything out. We just know middle terms will always cancel. So it's 5 times 5, which is 25. 4I times negative 4I, which is negative 16I squared. All right, negative 16I squared. You get 25 plus 16, because this is a positive 16. And 25 plus 16 gives us 41. And there is our final answer. So if you do conjugates like this with an I, you're going to get a regular number. You're not going to get an imaginary. All right. So for this one, all right, you have I squared times 4 times negative 3I times 2 plus I. All right. A lot of different ways of multiplication. It doesn't matter the order that you do it in. All right. What I'm going to do, though, is what is I squared really equal to? Well, I squared, isn't that just negative 1? So what I'm going to FOIL these two out, and then just whatever I get at the end, multiply by negative 1, which means change the signs. So 4 times 2 is 8. 4 times I is 4I. Negative 3I times 2 is negative 6I. So I get positive 4I, negative 6I, which is just a negative 2I. Negative 3I times I is 3I squared. All right. So then negative 3I squared is really a positive 3. 8 and 3 is 11. So I have 11 minus 2I. And then we're going to multiply just by a negative on the outside, which means it becomes negative 11 plus 2I. There's our answer. All right. All right. For number 11, I to the 437th. Don't worry about the whole thing. The only thing you really need to worry about is 37. All right. Don't need to worry about 437. It's just the last two numbers to figure out the remainder. So, I mean, shouldn't have to write out like this, but I'll just show you. 4 goes into 37 9 times. 4 times 9 is 36. So the remainder is 1. So it's the same thing as I to the first, which is just I. And there's your answer. All right, 12. All right, to get rid of, when we have a complex number on the bottom, we multiply the top and bottom by the conjugate. So we have 2 plus 4i. So I'm going to multiply by 2 minus 4i. All right, I'm going to multiply the tops. So I just distribute. 3 times 2 is 6. 3 times negative 4i is negative 12i. Conjugates, so the middles will cancel out. So it's just 2 times 2, which is 4. 4i times negative 4i, which is negative 16i squared. So I end up with 6 minus 12i over, this is positive 16 really, right? Negative 16i squared, same thing as positive 16, which becomes 20. But remember to split this up, all right? So it's 6 over 20 minus 12i over 20, and we could reduce that and simplify it. 6 over 20 is 3/10, and 12 over 20 is 3/5. So it's 3i over 5, or 3/5 I, however you want to write it. So it's 3/10 minus 3/5 I is your answer. All right. Moving along. Okay. All right. So for 13, all right, so we're going to have to multiply things out a few times here. It doesn't matter if you want to do first times second first, or second times third, or first times third. All right, I'm just going to do the first two times it. So I'm going to do this. I'm just going to FOIL that out. 3 times 2 is 6. I get 3 times 4i is 12i, but then I get negative 2i, which means that's 10i. Negative I times 4i is negative 4i squared. All right. They put the square there, sorry. Negative 4i squared is just really plus 4. So 6 plus 4 is 10. So I end up with those first two together is 10 plus 10i. Now I'm going to multiply that by the last one there, which is 5 minus 2i, and we do it again. All right. So now I do 10 times 5, which is 50. I do 10 times negative 2i, which is negative 20. And then I get a positive 50i, which is positive 30i. And 10i times negative 2 is negative 20i squared. Negative 20i squared is really positive 20. 50 plus 20 is 70. Make sure we're putting it in standard form of a complex number. And I get 70 plus 30i for my answer. All right. 14. Got to get rid of all this on the bottom, which means we got to multiply by the conjugate of 4 minus I root 2 on the top and the bottom. Okay. So up top, it's the same thing, right? So it's not a conjugate. So it's 4 times 4, which is 16. Then it's 4 times negative I root 2, which is negative 4i root 2, which I'm just going to double because there's going to be two of them, because you double the middle product, I get negative 8i root 2. Negative I squared times negative I squared. I times I is I squared, and then root 2 times 2 is 2, so it's positive 2i squared, which will change in a second, over conjugates now. So 4 times 4, 16. I root 2 times I root 2 is negative 2i squared, because I times I is I squared. Root 2 times root 2 is 2. All right, so now we change this. This is a negative 2. 2i squared, whoops. Positive 2i squared is negative 2. 16 minus 2 is 14. Minus 8i root 2. Negative 2, this turns in, negative 2i squared turns into a positive 2, which is an 18. And now I just need to separate it, right? 14 over 18 is 7/9. 8 over 19 is 4/9. So minus 4. Oops. sorry about that. 4I over 9 root 2. There you go. There's your answer. All right. 15. Okay. Now, what I would recommend for this one, you could convert each of these using cycle I first, then multiply them together, but why not just, since it's multiplication, 50 plus 60 is 110. So I get negative 8, because 2 times 4 is 8, right? Negative 8I to the 110. All right. Well, I to the 110 is I just worry about 10. 2 goes into 10. 4 goes into 10. Get a little dyslexic there. 4 goes into 10 2 times with a remainder of 2. So since it's a remainder of 2, all right, 8I to the 10th, I to the 1/10 is the same thing as I squared, which is negative 1. Negative 8 times negative 1 is a positive 8. All right. You don't only have to do the last two numbers to figure out how many times 4 goes into it. I mean, you don't have to do 110. You could, you'll still get the same remainder every single time. All right. So first thing I would do here, we have the negatives, right? So let's pull out the I. So 3I root 28 times I root 147. Okay. Now, when you multiply radicals, you do outside times outside. So I would get 3I times I, which is 3I squared, which is really just negative 3. And then I would multiply 28 times 147. Well, I don't care what number it is. Not going to be using calculators, but whatever 28 times 147 is, if I have to break it down and simplify it, well, I would have to do 28 and 147. Those are two numbers that go into it. So now I'm just going to break down each of these. All right, 28 is 7 and 4. So we have 2 and 2. So we have 7 and 2 2s. 147 is 49 and 3. So that's 7 and 7. All right. So I have a pair of 2s and I have a pair of 7s. 2 times 7 is 14, but I already have a negative 3. 14 times negative 3 is negative 42. What I did not use was this 7 and this 3. So that's on the inside of the radical. And you multiply those. 7 times 3 is 21. So I get negative 42 times the square root of 21. All right. All right, last 4. I think it's last 4. Yeah. All right. So once again, we have to get rid of I. It doesn't matter if it's not a complex number. If you just have something I, just multiply top and bottom by I. It doesn't have to be 5I. You can. You get the same answer, but it just take a little longer. All right. So I get negative 4I over 5I squared. 5I squared is just negative 5. So I get negative 4I over negative 5, which is the same thing as 4 positive 4/5 I. There you go. All right. All right, 18. We're just going to distribute here. We're going to distribute here. And then we're going to combine like terms, see what we got. Negative 2 times 8 is negative 16. All right. Negative 2 times negative 4I is positive 14I. Plus 6I. Nothing going on there. Then I have negative 23 times 4I, which is negative 92I. And then negative 23 plus 9 is positive 207. All right. So I have 14I, negative 92I, right? And then I have negative 16 I can combine with, there's another I, plus 2 is 7. So 2, because I want to do this in standard form, negative 16 and 207 is really 191. And then 14I plus 6I is 20I. 20I minus 92I is negative 72I. So it's 191 minus 72I. All right, 19. All right, so let's multiply this out. 4 times negative 2 is negative 8. So this is very similar to the one we did up here, right above it. And then we do 50 plus 18 is, what is that, 68? All right, well, how many times does 4 go into 68? 4 goes into 68 evenly, right? It's 17 times. So the remainder is 0. When the remainder is 0, it goes in even. That means it's I to the 4th, which is just 1. So it's negative 8. I to the 68th is really just 1, which is negative 8 times 1, which is negative 8. All right, last one. All right, I have to switch colors up one more time. All right, let's distribute. I get 21 I to the 4th minus 6I. All right. Well, 21 I to the 4th. I to the 4th is just 1, right? So it's 21 times 1 minus 6I. 21 times 1 is just 21. And we get the negative 6I. And there is our answer. All right. All right. So hopefully, if you had some questions, this helps out a little bit. Feel free to go back and check this at any time. Obviously, we'll be answering questions in class next time I see you guys. And that's about it. If you have any questions, please reach out. Hope all is well. And I'll be talking to you guys soon.